We're going to do it in under 4 minutes. There are practice questions for this as well as loads of other maths GCSE stuff at mathskitchen.com. Right, the language of circles. So that orange line there highlighted is the circumference of a circle. It's just the distance around the circle. An arc is just a part of the circumference of a circle. A chord is a straight line that connects 2 points on the circumference. It's just a straight line going across your circle. And the chord creates 2 segments. You can see them highlighted in blue there. Subtend is this word we use quite a lot in circle theorems, and it just means to create an angle at a particular point. You can see that angle on the circumference there highlighted in orange has been subtended from those 2 blue points. Those 2 blue points are either end of an arc, so we could say that it is the angle subtended at the circumference by an arc. Right then, theorem number 1. The angle at the centre is double the angle at the circumference. So this angle at the centre here will always be double the angle at the circumference there, and that is the case even if the angle on the circumference moves around like it is there. Theorem number 2. Angles in the same segment are equal. Any angle created or subtended from those same 2 points will always be the same size as long as they're in the same segment of the circle. In other words, the same side of those 2 points on the circumference. Theorem number 3. The angle in a semicircle is a right angle. So if we have a triangle where one of the sides of the triangle is the diameter of the circle, just like we got there, then the angle created at the circumference will always be a right angle. Theorem number 4. Opposite angles in a cyclic quadrilateral sum to 180 degrees. Well, first of all, a cyclic quadrilateral is a quadrilateral where all 4 vertices or corners are touching the circumference of the circle. And if you have a cyclic quadrilateral, then the opposite angles will add to 180 degrees, just as these ones here are showing. Okay, tangents. A tangent is just a line touching the circumference of a circle. You can see an example there. And if you take a line from the centre of the circle, in other words a radius, it will meet the tangent at 90 degrees. Tangents that meet at a point are equal in length. If you take 2 tangents from the circle and they meet up at a point as they do here on the right hand side, those 2 lines will always be the same length. Alternate segment theorem. The angle between a tangent and a chord is equal to the angle in the alternate segment. That's a bit of a mouthful, but it just means that this angle will be equal to this angle. I think of it as the angle inside the triangle is equal to the angle opposite and on the outside. So I think inside, opposite, outside. Finally, isosceles triangles. It's not a theorem, it's just worth noting that if you have a triangle where 2 sides come from the centre of the circle to the circumference, then you've got an isosceles triangle, and those 2 angles at the base will be equal to each other. That is everything you need to know about circle theorems. Don't forget to go and practice those at mathskitchen.com.
Hello and welcome to Teen Topics, where you'll be taught all you need to know about circle theorems. So a circle theorem is basically finding the angle within a circle, which has another shape inside it. These shapes are generally not drawn to scale, which makes it that little bit more difficult. But don't worry, in the next few minutes you will learn all you need to know about circle theorems. Okay, starting off. A chord is a line that lies anywhere below the diameter that goes from one side to the other of the circle. In this image, the perpendicular bisector of the chord passes through the centre of the circle. Number 2. Here we have a semicircle. Say we put another one on top and put a random triangle inside this half and name these angles A, B and C, then this angle B will become 90 degrees. But this is no fluke. Even if we have this triangle instead, or maybe even this one, they will always be 90 degrees. In fact, put any triangle here and it will still add up to, yep, 90 degrees. Number 3. A tangent is a line that passes the outside edge of a circle. When this line is touched by the radius, that means the angle will be 90 degrees. Number 4. A subtended angle is almost like our eyesight. When we look at an object, our vision is focused on that. Taking this tree and this man for instance, the subtended angle is 22 degrees. The subtended angle is basically the line, arc or object opposite to the inner triangle. Number 5. Angles in the same segment subtended by the same arc are equal. For example, ABC is the same as ADC. Number 6. When you have an arrowhead shape inside a circle, the inner angle here is twice this angle at the circumference. Number 7. The diagram shows a cyclic quadrilateral, which is a four-sided shape with all of its corners touching the circumference. What is different about this is that the opposite angles both add up to 180 degrees, so A and C would add up to 180, and B and D, same thing. Number 8. Going back to the tangents, if you do not remember, go back to number 3, then the lengths of the two tangents would equal the same amount. To explain that with a visual guide, length AB is the same as AC. Number 9. The angle between the tangent and a chord is equal to the angle in the alternate segment. This is also known as an alternate segment theorem. Here was quite a confusing looking sum that you are likely to get in a maths exam. Have a look at this image and have a go. Can you do it? Pause the video and see what you can get. Okay, so the sum we would do is A equals 180 minus 70. Divide this all by 2 and this will equal 55 degrees. As some people already know, the base of isosceles triangles will always equal. Now we get the 90 at angle B and take 55, which equals 35 degrees. How was I able to get this 90 degrees? Well, as previously explained, when a radius and a tangent meet, this creates a 90 degree angle. Now we have 35 degrees from the previous answer, we times that by 2 to get 70. Now we take it away from 180 degrees. Finally, we divide that 110 by 2 to give us 55 degrees. This is the angle marked D. Congratulations if this was your answer. If there is anything you do not quite understand, give me a shout out in the comments down below and I will happily answer your question. If you found it interesting or helpful, then maybe consider pressing that free little subscribe button down below. It really helps me out a lot.
Alright, while we were waiting for others to join, we looked at the video. So we just want to complete a couple questions on geometry and trigonometry. We want to look at the circle theorems. Then we want to go on to bearings, and we have vectors and matrices as well to do this too. Now, there were a lot of theorems that was discussed in those two videos. What I would like you to do is quickly draw the diagram and to identify if any of the lengths is a diameter. Go ahead. This is June 2019. Now remember, the diameter must come from one end of the circumference and it must pass through the center. If any of the lengths is a diameter, please label it on your diagram. All right, can anyone identify the diameter in the diagram?
A to C?
A to C. Who said that? Malik, you?
Yep, Malik Coffee.
All right, Malik, what is the theorem with the diameter?
Any straight line passing through the any straight line pointing through the middle of the circle is the diameter.
Right, and the diameter split the circle in how many parts?
2 parts.
2 parts. So the angle in the semicircle is a right angle, not so?
Yep.
So this here is the right angle. Can you all see that?
Yes, miss.
Now,
Yeah, ma'am.
I want you to work out, this is the right angle. If this here that I'm coloring in green is 90 degrees and part is 46, what is the missing part? X. Work it out.
Miss.
51. Akeem, what did you get?
50.
50. All right. Does anybody else have anything other than 50? And Shinika,
Yes.
what did you get?
So I get 44.
All right. Shinika got 44. Did anybody else get 44?
Yeah, miss, I get 44 as well.
Right. So Akeem, the two angles will give us 90 degrees. So this angle here must be 44. Right? Now, the first part of the question asks us for DBE. So let me show you what they're looking for. DBA. So they want this angle here. And DBA is 44 degrees. And the reason, because we have to give a reason, AC is a diameter and the angle in a semicircle is a right angle. So you must state the reason and you must state the value. So go ahead and take it out. So that was the first part. All right, are you all finished writing?
Yes, miss.
Yes, miss.
So the next one we want to find is DAC. So let's go to the diagram and I'm going to draw the lines DAC. So D, and I'm going up to A. And so if I have 3 letters together, the one in the middle is the angle that they are referring to, DAC. So they want this angle here. Who could tell me which theorem does this involve? Look at drawing another part there.
Quadrilateral.
Oh, it is a quadrilateral. But look, Look at it. Are the two angles on the same segment?
You see the timer?
No, I didn't hear you.
Yeah, miss. Yeah, it's on the same segment.
So what is the theorem with the same segment?
That the
angles on the same segment are?
Double the amount.
No, that is
equal.
the angle at the center mark. What is the theorem with the angle on the same segment?
Angle on the same segment is equal to the other angle.
Angles on the same segment are equal. Can you all remember that?
Yes, miss.
yeah, miss.
So what do I mean by the same segment? Remember, the chord separates the circle into two parts, into a minor segment and a major segment. You all remember that?
Yeah.
So this is the chord here. And this big piece here is the major segment. And this small piece here is the minor segment. So if this angle is 46 degrees, sorry, this angle, because it is on the same segment, bounded by the same arc, the angles are equal. So here would also be 46 degrees. So DAC is 46 degrees, and the reason is angles on the same segment are equal. So take it on and we'll look at the last part, because the circle theorems is worth 6 marks.
All right, finish, miss.
All right, give them a minute again. Are we finished?
Yes,
miss.
miss.
Yeah, miss.
So last part, we want BCE. So I already told you, when we have 3 letters together, the angle we are referring to is the angle in the middle. So we want to know the angle BCE. So let's go back. And let me erase some of these lines here. So BCE. So this is the angle I want to find. BCE. So how much is this angle here? Watch the shape. Is this on the same segment? Watch the shape. Look at.
Yep.
So here is 28, not so?
Yes, so that's 28.
So work out the value for me of this angle. If all 3 angles should give us 180. Work out this angle at X.
Done, miss.
How much is it?
106.
Who could confirm that?
Yeah, miss.
Yeah, miss, I can confirm that.
Right. Now, if this is 106, this here is a straight line, and the angles on a straight line is 180. So work out this part here. How much is it? 180 minus 106.
74, miss.
74.
74. So let's write the answer. BCE is 74 degrees. And the reason is angles on a straight line are equal. All right, let's do one more. So this is the June 2022. All right. So quickly draw the diagram and explain why HJM is 38 degrees. So take it out and explain why HJM is 38. HJM. Why is that 38 degrees? This is parallel and this is parallel. So I will give you the reason. When a transversal cuts two parallel lines, alternate angles are formed and they are equal. So therefore, this angle here is 38. And look, this is the transversal. And this is the two parallel sides. Can you all see it?
Yes,
You know
miss.
that it looks like a Z.
Yes, miss.
Are we finished writing?
Yes, no, miss.
Hold on, miss.
All right, finish, miss.
All right. Is anyone still writing? Is anyone still writing?
No,
No, miss.
We want to say MJK is 90 degrees. So let's see where that is. MJK. MJK. Why is this angle MJK 90 degrees? Could anybody tell me?
The diameter.
The diameter. Which side is the diameter?
MK.
Right. Very good, Malik. MK is the diameter. So the angle in a semi-circle is a right angle. Good job.
All right, finish, miss.
Right. The next thing we want to show is we want MLJ. So let's draw it. MLJ. All right. So we want this angle here. What information is given?
So look like an isosceles triangle.
No, that's not well, yeah, it's an isosceles triangle. Two lines there are equal. So which sides can we determine? We need to get a length.
We could determine J and H.
J and H. How much is J?
J is 38.
J is 38. Now remember
Well,
this
yeah.
is 90.
Yeah.
Here is 38. So if here is 38 and this is 90, can you work out this angle? If this is 90, watch. If this is a 90 degree and this is 38, can you work out this angle?
Yes, miss.
So work it out and tell me how much is the angle at K. Shanika said 52 degrees. Did anybody else get that?
yeah, miss.
Yeah,
Right.
miss.
Okay,
How do
miss.
we call this line? It doesn't pass through the center, but how do we call it?
Chord.
A chord. And what do you know about angles on the same chord? or the same segment. They are equal, not so?
Yes, they are equal.
So how much is angle X if this angle is 52? How much is it? I'm going to turn it upside down. You see in the angles are the same segment. How much is this one at X?
That's 52.
52 degrees. So the angle MLJ, let's write it. MLJ is 52, and the reason is angles on the same segment are equal.
Let me finish.
The last part now, we want LJK. So let us outline LJK. LJK. So we want this angle here. So let's see how we could figure out this angle. So what do we know? We know there's 52.
That's 38.
No, it's not 38. What other information do we know? Well, we know this is an isosceles triangle. Isn't this an isosceles triangle here? What do you know about an isosceles triangle? Look, the sign here. What do you know about an isosceles triangle?
The ends are equal.
The angles are equal. So this big angle here is supposed to be 52. So if that is 52, how much is this angle here? This little piece. How much is that little piece?
14.
14.
14. All right, so we're getting somewhere. Here's 14. Let's see what else we can figure out. So that is 52. Right. All right. We need to get to date. Did we work out 52? What angle is this then here? If this is 52, if this whole thing is 52, and this is 52, how much is that? How much is this one then? So 52 multiplied by 2 minus 180.
Sorry,
76. So remember we said this is a right angle because it is the angle on the semicircle. So if this is 90 degrees, how much is this missing piece here? The whole angle is 90 degrees. So how much is he missing piece?
14.
14 degrees. Do you all see how I figure that out?
Yes, miss.
So I
Yes,
am
that's confusing.
that confusing.
Yes, kinda.
All right, so let me do it in parts then. I'm going to erase it. So you all take down what you need and I will do it bit by bit. Tell me when you finish, right? Could I erase the diagram?
Yes, miss.
All right. What shape are you all seeing it?
We're seeing an N shape right now.
You see in an N.
Yep.
If I drew it like this,
Z, miss.
it looks like a Z. So when we have Z-shaped angles, we call this alternate angles. So it means this angle here is 38 and this angle here would also be 38. So the angle here is 38 degrees. You all understand that?
Yes, miss.
Yes.
Yeah.
So that is the first angle. Z-shaped angles, write it down, are called alternate angles. And the clue is you look for two parallel lines. The clue, look for two parallel lines. All right, are you all finished?
Yeah, miss.
All right, this is the next part now. How do we call this line here in orange?
We call it
The diameter.
How you know that is the diameter?
The pass on that.
That's
Pass
the
through the middle.
of the circle.
All right,
Circumference of the circle.
so I erase this line. It passes through the center. So you know it is the diameter. Yes?
Yes.
Yeah, miss.
You see in that this angle here is half of this is in half of the circle.
Yep.
Right? So this is 90 degrees. And this is a right angle triangle. Look at it. Can you all see that?
Yes, miss.
Yeah,
So
miss.
that is the second reason. You all following so far?
Yes, miss.
This is the second reason, miss.
This line here is the diameter. So from the time you spot the diameter, you're looking for a 90-degree angle. Because a diameter splits the circle into two parts. So it means one angle is 90 degrees. You understand so far?
Yeah, miss.
Yes.
Right, we're going again. No. So the next one was MLJ. So to find MLJ, I'm still going to write this. I don't need this as yet. So I'm going to take off this so you could see it properly and you could see it clearly. Now, this line is called a chord. You all agree?
Yes, miss.
Yes.
Right? This chord separates the circle into the minor segment and the major segment. Yes?
Yes.
Right? Now, this angle should be equal to this angle because they are on the same segment. Not so?
Yes.
Miss.
Right? So if this here is 90 degrees and this angle is 38, how much is this one here?
52.
52. And if this is 52, the other angle is also 52. You with me so far?
Yeah, miss.
So it's
Yeah,
it's
miss.
seeing the angles on the same segment, right? Right. So we want to work out the last part, which is this little piece here. This angle. So watch how we're going to do it. Now, I know this is an isosceles triangle. So if this is an isosceles triangle, here is 52. So here must also be 52. So if this whole angle is 52, what is this part here? What is that part?
14.
14. And what is this part here? Because here is 52, here is 52. What is the missing angle here? How much again to make 180?
76, miss.
76. So if the whole angle is 76 and this whole angle is 90, wouldn't this piece be 14?
Yeah,
Yes.
miss.
Right? So you all understand that?
Yeah.
Yes, miss.
Right? So sometimes we have to look for clues. One clue is two parallel lines. That will indicate it is a transversal and alternate angles are formed. Another clue is to look for the diameter. When we spot the diameter, we know the angle in a semicircle is 90 degrees. Another clue is to look for the angles on the same segment. Once the angles are on the same segment, they are equal. And we know isosceles triangle have two angles that are the same. Yes?
Yes, miss.
Yeah, miss.
Right. All right, so we continuing. Look, isn't this circle theorems? Isn't that a circle theorem? Question 56, isn't that a circle theorem?
Yes, it is.
Yes.
When we look for the arrowhead, what is the rule with the arrowhead?
When the larger segment is doubled,
It's doubled. So how much is y, Malik?
how much is y? Y is 100.
Do you all agree with y is 100?
Yeah.
Yes, miss.
And the rule is the angle at the center is twice the angle at the circumference. And this is a repeat question that CXC likes to bring. Let's see what else. So that is January. Let's see for June. Let me see what they brought for June. June. $2020. All right, look at this triangle. What is the size of angle X? What type of triangle is that?
It's an isosceles.
Hustles.
It's an isosceles. What is the rule with the isosceles triangle? Two angles are equal, not so?
Yes,
Yeah,
two
ma'am.
angles.
So how much is angle X?
120.
Who could confirm that?
And confirm that?
Yes, it is 120. So you see how, do you all see how the question comes, and the question is pertaining to the topics. So let's see what else we can find. This one we did already. June 2020. The question repeated. Oh, my screen stopped sharing. Sorry about this. All right, the question here again. So this one is a repeat question. You see it comes on the front here.
Yeah, nice.
All right, let's see if there's any in Jan 2021.
Yes, I think you pass it.
Look here. How much is the angle?
100.
100. Watch this one. In the diagram, PQ and RS are parallel. So we're looking for a Z shape. Which relation best describes X and Y?
X plus y is 180.
No,
Oh, number man.
this is the transversal. When a transversal cuts, alternate angles are formed. Remember that?
Yes,
Yeah,
yes,
miss.
yes. No,
And watch the Z. This is the Z shape. So Z shape angles are equal. So it means the angle at X is equal to the angle at Y. So
Right.
the answer is
Yeah.
A.
Okay.
Right?
Yes,
You
miss.
all-
Yeah, miss.
Right.
Yes, miss.
So we're going to take a break. It is 5:26. We're finishing at 6:30 today. It is 5:26. You all come back at 5:40. When you come back, we're going straight into bearings. All right?
I miss.
Okay, miss.
Sometimes trig ratios or even Python add bearings.
Can you all hear the video?
Yes, miss.
For CSEC mathematics, it is an application of what we have learned in trigonometry, such as sine rule, cosine rule, area of a triangle, sometimes trig ratios, or even Pythagoras theorem. But for today's examples and lessons, we'll focus on applications of sine rule and cosine rule. So cardinal points shows the four main directions as shown in the diagram.
All right. So the four main cardinal points are north, south, east, and west. Correct?
Yes. Yes.
Right. So I want you quickly to write cardinal points and draw north, south, east, and west. Quickly. So you're drawing this in a book. And you're writing cardinal points. So we must know the cardinal points and the direction for us to do bearings.
All right, finish, miss.
All right, does anyone say write it?
No, miss.
We have north, south, west, and east. In some questions, we will be required to do a diagram in terms of if they tell you that a vehicle is traveling in the eastern direction or the southern direction, you need to know in the sketch of a diagram which direction that is. But for today's lesson, the most important direction that you need to remember is north. The north line is always pointing upwards.
And bearings are always measured from the north line, right? So let's continue.
What is a bearing? So a bearing gives a direction in terms of an angle from one point to another or with reference to a particular point. So the bearing of point B from point A, that means what direction B is from point A.
All right. So a couple things. We have to look at the word from. The word from tells us where we are going to set up this north line. On the screen, we have a bearing of. So we are measuring the bearing of from. So from the time we can identify from, it tells us at that point we are going to set our north line. So this is my north line. What am I measuring? I am measuring the bearing of the angle from the north line to B. Do you all understand that?
Yeah, miss.
So from tells us where we are going to measure. So let's write a note. So underneath, you're going to write the word bearing and you're going to write what I have here. So I'm going to type it. A bearing is a measure of an angle in a clockwise direction from the north line. Then I want you to draw this diagram here. And you're going to write next to it from A, place the north line at A. Of B, measure the angle from the north line.
Must this is a draw this, right?
Yeah, and you're writing what I have in black, right?
I must finish.
Is anyone still writing?
No, miss.
No,
Right.
miss.
Let's continue.
However, our direction in this case, to be very specific, we are not going to use north, south, west, and east. We are using degrees or bearings, which gives us a more accurate direction. So, a bearing is a measure of the angle in a clockwise, then.
Okay. Also, the bearing of A from B. So what I want to emphasize now, from is before the letter B. So from B is where I am going to set up my north line. So if I set my north line here, I am going to measure the bearing of A from B. So this is the measure of the angle touching this line. Do you all understand the difference here?
Yes, miss.
Right? So I want you to take down the diagram, and next stage you're going to write the bearing of A from B.
Miss, so we taking down the diagram
And you
again.
write, yeah, this is a new diagram. And you're writing this underneath. Just the part in black. What I have typed, the bearing of A from B.
I'll finish, miss.
All right.
So I never finished.
Go ahead.
Okay, finished. Yeah.
Now, if we are looking at questions to get since alternate angles are equal, that alternate angles are equal.
Here we meet up alternate angles again. So alternate angles are equal, they are Z-shaped, we know that. So let's look at the questions.
On a straight line add front to 0 angle triangles.
Also, bearings are expressed using 3 digits. So if the angle is 35 degrees, we write a 0 before it. So we want to write that. 1, we write bearings using three digits. Example 035. To solve questions involving bearings, we use the sine and cosine rule. All right, so take that out.
All right, finish this.
Okay, example 1, we are going to look at a
So I want you to draw the diagram. And this is from January 2014. Go ahead.
All right, finish this.
Right? Are we finished? Let's see what they want us to find.
Yeah, nice.
A past paper question, Jan 2014, number 10, part B. The diagram below shows the position of 3 points P, Q, and R on a horizontal plane, that just means a flat surface, where PQ is equal to 120 kilometers, as shown on the diagram here from P to Q. Then we have PR equal 150 kilometers and QPR equal 23 degrees. All of that information given is represented on the diagram. The first part of the question wants us to calculate to 1 decimal place the distance QR. So as seen in the diagram, this is the distance that we want to find, QR. We have a triangle in which we are given two sides and an angle.
All right. So this is what type of triangle?
Isosceles.
No, isosceles has two
Oh,
sides
goodness.
that are equal.
Yeah. Yeah, sorry, my bad. It's a right angle, right side angle.
No, it have no right angle here. It's a scalene, not so?
Okay, yeah, that's right.
What information we have about triangle PQR?
Yeah, that degree of 23.
We have two sides. And what else? And the included angle, or the angle in between the two sides. You all see enough?
Yes, yes.
So this tells us that we have to use the cosine rule. For two sides and the included angle, we use the cosine rule. Now, the cosine rule is, so write that and let me tell you what the cosine rule is. So this side, we will label it as side C. This side, I will label as side A. And this side, I will label it as side B. So we have A, B, C. Do you all see that?
Yes, miss.
So the cosine rule is C squared is equal to A squared plus B squared minus 2AB cosine of angle C. And it is given in the front cover of your booklet. So I want to find C. So C remains as is. What is the measure of angle or the length of A? How much is A?
120, miss.
So this is 120 squared. How much is B?
150.
Right?
Good.
So it's 150 squared minus, and I put it all of this in bracket. 2 multiplied by 120 multiplied by 150 multiplied by cosine of 23. And I put in everything in the calculator and I given me an answer. So when you finish, write it, try it.
This is these structured questions, right?
Yes, yes, yes. This is paper 2. So the circle theorem is the first part, Chinika, and this is the second part of the question. I want you to put everything in the calculator.
This we averaging it to 3
Give
decimal
me,
places, eh?
yes, give me to 3 decimal places because we have to find the square root. What did you get? I want you to get in the habit of using the calculator.
1,761.825.
Who could confirm Angelina's answer?
Me, miss.
Yes.
Right?
I confirm that's the
Right.
answer.
Now, here's how we're going to find C. You're going to find the square root of 3,761.825 and give me correct to 2 decimal places.
Sixty-one point 33.
Yes, 61.33 kilometers. Did anybody else get that?
Yes, miss.
Yeah,
Very
miss.
good. So this is an application of the cosine rule. And as I mentioned, if you can't remember, it is listed in the front cover of your booklet. So can we continue?
Yes, miss.
Is anyone still writing?
No, miss.
And we need to find the P. This is 500, but once it's specified, you need to find 23, which gives AB are the two sides, and on the left hand side, I have the triangle PQR.
So this is another part of the question. To find the area of the triangle, what is the formula for area? Area of a triangle is?
Like that.
Repeat that, Malik.
Like that.
No, that is a rectangle.
Oh, my bad.
Area of a triangle is? Does anybody remember? All right, so area of a triangle is base by height over 2. Do you remember that?
Yeah,
Oh,
miss.
yes, miss.
Right, but we don't have any base and we don't have any height. So this triangle here, let's see how we are going to work it out.
And we learned our formula for
Right. So because this triangle has no altitude or height, we have to use the formula a half AB sine C. So let me go back here. Right. So we labeling it.
the triangle.
Here's A. Here's B. Here's C. The formula is area is a half AB sine C. Go ahead. Work it out.
Miss, I get the answer.
All right. What did you get?
7,896.
Did you find a half? Did you multiply it by a half?
By half?
Yes, it's a half AB sine C. Did you multiply
Triangle
the answer with by
PQR,
a half?
and we learned our formula for area of a triangle in the last video tutorial, where we have area is equal to a half AB sine C, where AB are the two sides that are adjacent to the angle or touching the angle. So if this is my angle 23 degrees, the two sides that I'm going to use would be the 120 and 150. So substituting into our formula, we would have a half by 120 by 150 sine 23, which gives 3,516.6 kilometers.
All right. You found the answer, Angelina, but you didn't multiply by a half.
No, Miss. When this says sin C, I didn't put 23. I put the answer that we get before. I put
Oh,
like
okay,
the
okay,
60
okay.
something. Yeah.
All
Me
right. Well,
too.
clear the calculator and put for me a half multiply by 120 multiply by 150 sine 23. Go ahead.
Okay, Miss, I get the answer.
All right. Did everybody get the answer? All right.
degrees. Calculate the bearing of R from P. So
here we want to calculate the bearing of R from P. So if we calculated the bearing of R from P, where are we going to set up this north line? We want the bearing of R from P. Where are we going to set up the north line?
P?
At P. Didn't I tell you all where you see the word from is where you're setting up the north line?
Yes, ma'am.
All right. So let us look at a past paper question. So we are looking at the 2022 June paper. The question reads, from a port L, ship R is 250 kilometers on a bearing of 65 degrees. From where?
Port L.
From L. So if I have to set up my north line, it will be from L, not so?
Yes, Miss.
Yes.
Right? So I draw in my north line, bold, so you all can see it. The bearing from L, the bearing of R. So this angle here is how much? How much is the bearing?
0.65 degrees.
65 degrees. You all with me so far?
Yes, miss.
T is 180 kilometers, L is 148. The ship T is 180, and from L, the bearing from L, the bearing of T is how much? How much? From L,
148.
right? So this bearing here from L to T is 148, not so, Angelina?
Yes, Miss. Yeah.
Right. So how much is this angle here? The whole angle is 148. Part is 65. How much is this shaded part here?
83.
83. Who said that? Shirika, you?
Yes, Miss.
You all agree this is 83 degrees?
Yes, miss.
Yes, miss.
Right, so I want you to take down the diagram. You're writing for me June 2022. And we're going to work out the question. So this is how the question comes. And circle theorem and bearings is a good question for us to score full marks, as long as we understand the concept of bearings.
That, miss.
Right. Everybody is finished?
Yeah, miss.
Right. So we did the first part. Which length do we want to work out? The length RT. You all seen it here?
Yes, miss.
Yes, miss.
We have two sides and the included angle.
Yeah.
So which rule are we going to use? For two sides and the included angle, which rule?
The cosine rule.
The cosine rule. So the first thing we have to do is label it. So we're going to use the cosine rule. So label for me A, B, and C. The missing side, we're going to call it C. This is A and this is B. The formula is C squared is equal to A squared plus B squared minus 2 AB cosine C. Let me know when you will have an answer. C squared is equal to all right. Anybody with an answer? C squared is how much? What is the answer? No, that is incorrect. Try it, clear the calculator and try it. 250 squared plus 180 squared minus open bracket 2 by 250 by 180 by cosine of 83, close bracket. Anybody with an answer?
Just numbers.
No, Akeem, that is incorrect as well.
Miss, I have an answer, but I'm not too confident, but I still going to say it.
Go ahead.
83,000. I said that wrong.
Yeah, 83,900.
And 31.759.
That is correct. So C is the square root of that. Those of you all who didn't get it, clear the calculator and try it again for me. And the answer to 2 decimal places.
I have the answer, Miss.
Go ahead.
289.71.
Kilometers, right?
Yeah.
So those of you all who didn't get it, clear the calculator and practice it. That is the correct answer. Now, we did a lot of work today. We reviewed circle theorems. We did some questions. I introduced you to the concept of bearings, and I taught you how to use the cosine rule. In next week's class, we are going to look at the sine rule. Did you all understand the material that was covered today?